Here's an introduction to angle relationships. The most basic angle relationships happen when two lines intersect. When two lines intersect, there are a whole lot of angles that are formed. Let me give a sense of it. Here's A, B, C, D, E. How many angles can you name? You can name 4. What are they? Okay. AEB. And did you say CEB for this one? Is that what you said? Yes. Okay. So these 4? Okay. Anybody name any others? AEC. Is that an angle? Right. Remember, what's the definition of an angle? An angle is formed when? Right, 2 rays have the same end point. Well, these are opposite rays, 2 rays that share an end point and create a line, but they also meet the definition of an angle. Yeah. DEB. And DEB, yeah. Now, there are other names you could make for these. You could call this CED or BEC or AED. But you'll notice the one thing they all have in common, E is the center letter because E is the vertex. E is the place where the 2 lines intersect, and it is the end point that all of the rays share. All 4 rays share that end point. These 2 angles, AEC and DEB, are called straight angles. And if you'll notice, DEC and CEB, they are adjacent angles. Does anybody remember what makes adjacent angles adjacent angles? Yeah.
Angles that share a vertex and a side that don't overlap.
Right. They share this vertex, they share this side, and they don't overlap. Now, these are adjacent angles that have one more characteristic. Their non-common sides form a line. You see that here? You've got this angle here. You've got this angle here. You've got EC is the side that they have in common. E is the vertex that they have in common. They don't overlap. And ray ED and ray EB are opposite rays. They form a straight line. That makes these a linear pair. The definition of a linear pair is 2 adjacent angles whose non-common sides form a line. How many linear pairs can you identify here? I've already given you 1 pair, right? These 2? Any others? Yeah. Yes. Angle DEC and angle DEA. What else? Yeah? Right. Angle AEB and what did you say? AE and BEC. There we go. That works. Any others? Yeah.
Angle D.
Yes. Angle DEA and angle BEA. Okay. So this one and this one, this one and this one, and this one and this one, and this one and this one. Now, the fact that they are linear pairs means they are also supplementary. 2 angles are supplementary if their measures add up to 180 degrees, which is the measure of a straight line. Supplementary angles, their measures add up to 180 degrees. Each one of those pairs is supplementary. Is there a difference between supplementary and a linear pair? Can you come up with angles that are supplementary but are not a linear pair? Well, not on this drawing, but if I drew another pair of angles, how about this? X, Y, Z, and R, RTS. Now, assuming for a minute that this becomes a straight line and that these two angles do in fact add up to 180 degrees, those would be supplementary, but not a linear pair. You guys see the distinction? If we go back for a minute to the list of linear pairs that we've created here, and we write out what that actually means, what we get is that the measure of angle DEC plus the measure of angle CEB is equal to 180 degrees. And the measure of angle DEC and the measure of angle DEA is equal to 180 degrees. Now, I know that because we said that DEC and CEB are a linear pair, and DEC and DEA, they're both linear pairs. That's what was given. Here's our statement. Here's our reason. How come I can say this? If I've said this, why can I say this? Anybody know? What's the relationship between this statement and this statement? Not always, right? I just showed you a pair of supplementary angles that weren't, right? But what did we say the definition of a linear pair is? Adjacent angles whose non-common sides form a line. And we said, well, that means that the sum of their measures adds up to 180 degrees. This is the definition of a linear pair. It's not the whole definition, but certainly it's part of it. If I know they're a linear pair, I know this about them. I know that the sum of their measures is 180 degrees because their non-common sides form a straight line. Now let's look at this as an algebra problem. What can you tell me about this? What can you do with this algebraically to prove something new that you didn't have before? No, this says the measure of angle CEB. We're not multiplying by m. This is the measure of angle CEB, the measure of angle DEC. So these are numbers. This is like saying x plus y equals 180 degrees, x plus z equals 180 degrees. What can you do? Well, here's something that should jump out at you and scream at you right away, right? If I have x plus y is equal to 180 degrees and x plus z is equal to 180 degrees, which is what I have here, because this is x, it's the same number. And these are two different numbers, y and z. What can I do to this? Yeah, right? The transitive property says that the measure of angle DEC plus the measure of angle CEB has to be equal to the measure of angle DEC plus the measure of angle DEA. That's the transitive property. If two things are equal to the same thing, they are equal to each other. Okay? So now, writing it again in this algebraic form, x plus y equals x plus z. That's what we've got here, right? What can we do now? Right? We can subtract the measure of DEC from both sides and say that the measure of CEB is equal to the measure of angle DEA, right? And that's the subtraction property of equality. And of course, there's one last thing I can say here that's actually pretty cool. Angle CEB is congruent to angle DEA. The fact that their measure is the same is the definition of congruent angles. Okay, so we've got this, this, this. And what we've proved here is actually something kind of interesting. Which ones are those? CEB and DEA. CEB, that's this one here, right? And DEA, that's this one here. We just proved that those two have to be congruent. And we could probably do it again with these two angles to show that these two, this one here and this one here have to be congruent. These pairs of angles, the congruent ones, the ones that are across from each other, those are called vertical angles. I'll give you a definition that will work for you here. Angles are vertical angles if, and only if, they share a vertex and their sides form two lines. So that's these two right here. See if I can see if the highlighter shows up on the. Oh yeah. That one and that one. And then this one here and this one here. I have two pairs of vertical angles. So every time two lines cross, you create four linear pairs and two pairs of vertical angles. The linear pairs are supplementary, which means that the sum of their measures is 180 degrees. And the vertical angles are congruent, and that's the symbol for congruent. So those are your first angle relationships, and they are formed anytime two lines cross. There are more angle relationships, and we will get into them.